Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam. Free online classes in a chapter on friction. So we have to learn without friction. We have to teach also without friction. Means cool. Are you all cool? Okay. If not cool, become cool. Drink some cold water. Be cool, okay? Now have a book and pen. Any important points you can note down, okay? Shall we see some figures now? That is just to forces could be a push or a pull on a body. In the previous chapter we studied about forces. What is a force? It is a push on a body or pull on a body. Suppose you push a book, we say you applied force. If you push a table, it means you are pushing, means you are applying force. Similarly, if you pull a table or a chair or whatever it is, then we say force is applied. Why does a force take place? That is, it arises due to interaction between two objects. For example, if you have a hand and if you just go on beating like this, nothing will change, correct? There are two objects. There should be a book or a table or a person, something. So two objects are needed, correct? That is how we have studied in the previous chapter. Also we have seen force per unit area is called pressure. Pressure also is a very important aspect related to force. And how do you write the formula for pressure? Pressure P is equal to force per unit area. If the force is more, pressure is more. The force is less, pressure is less. At the same time, if area is more, pressure is less. If area is less, pressure is more. That is why it is called as inversely proportional, pressure and area. Okay? And also we have seen about atmospheric pressure, pressure in the liquids and gases and so on. We have studied. And also we have studied about contact forces and non-contact forces. The forces like muscular force, where they are touching a body, pushing or pulling, etc. There is a contact is there. That is called contact force. Non-contact means, so for example, magnetic force, electrostatic force, gravitational force, they are all called non-contact force. And also in our daily life we come across with the word called friction. When two boys or girls, when they clash each other, say friction has taken place. Of course, you are all very good boys or girls, but usually outside what happens? Silly things they fight. Is it not? They fight for eatables, fight for pens, pencils, books, silly things. And in daily life, let us just recall what are the situations where you get friction. See here, what is this boy doing? He is coming running, like some of you. He has a school uniform, you can see. What does he do? He presses the peels of the banana. What happens if he presses the peels of the banana? He has not seen it. If he has seen it, of course, he would have been careful. You have not seen it. He pressed the banana peels and he falls down. So why do we slip when we step on the banana peel? So the boy who was like this, after pressing the banana peel, become like this. Correct? So that is why they are asking. Let us see one more example. Why is it difficult to walk on a smooth and wet floor? The floor is wet. Means what? If some water has fallen down to the floor, which is very nice, say of marble, okay, then what happens like this? And there will be some boys or girls who laugh at it. You should not laugh. When anybody is in difficulty, you should not laugh. Okay? You are not supposed to laugh at it, because a day may come when you also fall. Now you may laugh and enjoy. But when you fall, hundreds will laugh. That's why, so unknowingly it happens, because of lack of common sense. And sometimes you can't see the water also on the soft surface. So see here, one more interesting thing here. What is this about? See here, it is a traffic signal. How many have seen traffic signals? Of course, city boys daily experience. There will be 3 signals. Red, what does the red stands for? Red means stop. All the vehicles should stop when the red signal is seen. And orange means, yellow means change. Change is taking place. And green means start. Start moving, that is green signal. And this is another symbol wherein it is shown that don't take right turn, no right turn. That is the symbol. So like that, there will be what is called as traffic rules. So this is a circle. Here it is 4 roads are connected to this circle, and this type of signal will be there. So by seeing the signal, we have to take decision. See, now a car is coming. So until this blue car goes this side, this red car, you have to stop it there. Is it not? Why should you stop? Suppose he also goes. What happens? There will be friction. There will be clash. Sometimes when both the vehicles are in high speed, difficult for them to stop at that stage. Correct? So now question is, how and why do these things happen? What are these things? A driver of a car or a truck slowing down the vehicle at a traffic signal. Everybody has to stop except ambulance. For ambulance, there is no stop. They will go straight because emergency. How do you identify ambulance? There will be some signal. Correct? So driver of a car, a truck or a bus even, all have to stop there at the signal. Is it not? Any object moving over the surface of another object slows down when no external force is applied on it, and finally it stops. Suppose you roll a ball on the floor. It goes to some distance and then it stops. Correct? So that is what we see. So here there are two objects. One is a rolling object, another is a floor. So we see that after some time that it slows down and stops. Similarly, when you slow down your bicycle whenever needed by applying brakes. How many know bicycle riding? All. Good. So what happens when you go in bicycle, suddenly a dog will come in the middle. What do? You have to apply brake, correct? Or a sheep will come. Some child will pass in front of you. So you cannot say that I am an expert driver, I can do anything you want. No, at that time you have to stop. How to stop it? You have to apply brakes, correct? So we slip and fall when we step on a banana peel. So if you are not noticed, you will avoid it. If you are not noticed, what happens? You are going to press it. And if you are in a speed, when you press it, you will fall off. Also, a ball moving on the ground stops after some time. You have seen cricket match. How many have the habit of seeing cricket match? Okay. There when a batsman hits, of course, except sixers. For sixers, he will lift it up. All other shots, he will hit it. Sometimes he hits hard. It go up to the boundary line. It touches the boundary line and stops there. Otherwise, in a small touch, if it gives, slowly it goes and stops. So, why does it stop? Why does the ball stop after some time? These are all the activities we have seen, or these are all questions arises, and for answer for this, it's difficult to walk on a smooth and wet floor. The floor is wet. When it is very difficult to walk on that, you must be careful, especially in bathrooms. You have to be extra careful. There may be some oil, there may be some soap, some other soap powder, this, that, fallen on the ground which is wet. So I suppose you stamp it, you have to be very, very careful. So, what is the cause for all these happenings? All this. The cause is frictional force, because of friction. In all these situations, no force appears to be acting on the object. Yet their speed gradually decreases and they come to rest after some time. We don't see any forces acting outside. Is it not? For example, when a ball is moving on the ground, we are seeing the ball stopping shortly and there is no force there. The force of friction always acts on all the moving objects and its direction is the opposite direction of the motion. It's a very important statement. So, here this happens because of force of friction. It acts on the moving object. Suppose you hit a ball by a bat. It goes to some distance and stops. And then, why does it stop? It stops because of friction. What kind of force it is? It is opposite to the direction of motion. So, because of that opposite force, it is bound to stop after some time. Correct? See here, it is a table, smooth table. He has kept a book here and that book was pushed to this distance by the hand. And here also, the book was shifted. Correct? If you gently push a book on a table, you will observe that it stops after moving for some distance. So if you push a book, it will move to some distance. Repeat this activity by pushing the book from the opposite direction. See here from say south to north, or if you push from north to south, or east to west or west to east. Then what do you see? Book also stops. Even if you push it so hardly, after some time it stops. Again due to friction. There is a force acting on the book opposing its motion. This force is called the force of friction. Are you following? Following? Correct. So I think very simple this is. Here is a man or a boy who pushes the book in this direction. Okay, and here is another individual who pushes in the opposite direction. After pushing for some distance it moves and then it stops because of force of friction. You can experiment with anything like that. And that too, if the floor or the table is very smooth, it go for a longer distance. If the table or the floor is rough, it will not go for long distance. You might have seen toy cars. Toy cars, you give the key and leave it. What happens? It goes fast to some distance and then stops. Again due to friction there between the car and the floor. Okay. So what you can conclude now? We can conclude that friction opposes the relative motion between the surfaces of the book and the table. Opposes. There will be some boys or girls even. Whatever is told, they will say negative. No, not possible. I don't do it. I don't want. All negatives. So like that is friction also like that. It opposes the relative motion between the surfaces of the book and the table. So why does the book stop there? Because there is an opposition force. And that is what is called as friction. Okay. And let us see one more activity. So a brick is tied to a spring balance and applied some force to it. So this is a brick. All of you seen brick? Plus shape of the brick. Correct? Cuboid. Okay. What is this here? It is a spring balance. And it is a thread. So what did the gentleman do here? He pulled this brick towards him. And when he pull it, there will be force acting on it. Correct? So the reading is to be noted on the spring balance when the brick begins to move. So when you start pulling up, you have to note the reading. Okay? It gives a measure of the force of friction between the surface of the brick and the floor. So this is the floor, this is the brick. So when you start pulling the brick, it shows some reading. And now repeat the activity by wrapping a piece of polythene around the brick. You take some plastic sheet and cover it. Now you try. What happens? There will be change now. The reading of the spring balance is noted again. So when you start pulling, it comes slowly. Why does it come slowly? Because of the polythene bag. Correct? So there will be reduction in the reading, measuring the amount of friction. So empty brick, it was showing one reading. And if it is covered with plastic and dry it, it shows the second reading which is less than the previous one. Why does it become less? Because of the friction of the polythene with the table. How do you know it? That is by the help of spring balance. Now let us see what is the spring balance stand for. Have you seen this type of balance? Yeah, usually it is seen in the paper shop or any gujari shop. So here this acts on the principle of gravity. So here this is a spring balance, it measures the weight of the substance, whereas the physical balance measures the mass of the substance. And this weight, this changes from place to place because of gravity. So device of measuring the force acting on an object. So suppose you hang any object here, that weight of that object can be measured here by the index. Here an index is 0 to 100, each divided into 10 parts. So 10, 20, 30, 40 like that, up to 100 it is there. Here is an index here, and how does it move? There will be a spring behind it. When the spring is pulled down, here is a hook. Okay, when the spring is pulled down, the force will be acting on it. It consists of a coiled spring. Behind, if you see, there will be a coiled spring. That's why it is called as spring balance. What is the other nature of spring? When you press it for some time, it becomes smaller. If you leave it, what happens? It jumps up. Correct? Spring, you all experienced it. So, it consists of a coiled spring which gets stretched when a force is applied to it. So, when you keep some weight hanger here and keep some weight, and this index will come down. Index will move down depending on the weight here. Suppose this is the weight. So depending on the weight, this spring will come down, and it shows the measure of the weight that is hanging here, a measure of any body, weight of the measure. So stretching of the spring is measured by a pointer moving downwards, moving on a graduated scale. This is a graduated scale, 0 to 100. So when you stretch the spring, this index will go on coming down. So what does it show? It shows the magnitude of the force, quantity of force. Of course, the formula is W is equal to mg. What is W? W stands for weight, and it is a kind of force here. Can you tell me what kind of force it is? W is equal to mg. What kind of force it is? Acceleration due to gravity. G stands for acceleration due to gravity. And this is a force connected with gravity. Formula is W is equal to m into g. What is m? M is mass. G is acceleration due to gravity. What is its value? 9.8 meter per second square. G value. So again it is a force here, and it pulls it down. If there is no weight, it comes to zero, back to zero. Okay. Now look at these two guys, very smart guys. How many of you are smart there? All? Yeah. Look at them, neatly dressed. Look very active, cute boys. What they are doing here? Here is a table, and here is a inclined plane. What is it called as? Inclined plane. On a smooth floor, So this is a smooth table, and you may use a wooden board supported by bricks. So this is a wooden board, and these are the bricks, or you may use books also. On that you have to keep the wooden board. A marking is made with the pen at any point A on the inclined plane. So draw a line on the inclined plane. So what you have done here? You have taken a table. On the table, you have kept some either bricks or some books. On that you are keeping some wooden plank, inclined. Can I use some more examples of inclined planes? Yeah. All of you are interested in that game. There will be a game on the inclined plane. One of the portions you can climb up. There will be steps. And 3 portions you are going down. Smooth it is made up. Very interesting game. Correct? Something like a seesaw. So here, what they have done it? They have marked the point A on the inclined plane. And then what you have to do? Let a pencil cell move down from this point. From this point, they will allow the pencil cell. So it is made to roll there. It is cylindrical in shape. So it is made to move down. Note the distance it has moved on the table before coming to rest. So the pencil cell, what is kept here, comes down and it comes to rest at a point. Now, because it is smooth surface, it goes to some distance. Instead of the smooth surface, suppose you have spread a piece of cloth over the table. So here a piece of cloth is kept. So here it is a pencil roll. So if it is made to roll down, what do you expect? Will it move faster or slower? Slower. Why? Because there is a cloth here. What does the cloth do? It creates friction. So what is your observation? The speed of the pencil roll will come down because of friction. One more case. Suppose you have a layer of sand. Instead of cloth, if you put some sand and try that experiment of inclined plane with a marking point A, you leave a pencil roll. It comes still slower. Earlier it was very fast. Then second case it came a little slower. Third case it is still slower. So what do you observe? Observation is pencil cell covers less distance when the surface is rough. First case it has moved to a large distance. Second case little less. Third case, when you use sand there instead of the plastic sheet, then what happens? It goes still slower. Why does it do so? It does so because of friction. So more the friction, slower will be the body, moving body. Lesser the friction, then more will be the speed of the moving body. Now coming to home assignment. What is friction? Give one example. It is difficult to walk on a smooth and wet floor. Why? You spilled a bucket of soapy water on a marble floor accidentally. Actually it happens in bathrooms and toilets. So by miss you have spilled a bucket of soapy water. Would it make easier or more difficult for you to walk on the floor? So if soapy water is there, is it possible to move on that? Of course, you can move. But how you must explain? Now let us see what Sadhguru says. Sadhguru Sai says, see, just like in a school, students keep changing, but the teacher who teaches the subject remains the same. So, same teacher, same subject teaching. But students will come and go. As the batch finishes, the teacher is teaching 8th class. When the exam is over, they will go off to 9th. Next batch comes there, 7th to 8th. Next year, next batch comes. So also, God is permanent. Bodies will come and bodies will go. Bodies are temporary. God is permanent. Okay, come prepared with the answers. Thank you.